open discussion on how to enable efforts in this space. And, yeah.
So the bioinformatics and genomics community, they're using, workflows much more like Galaxy,
yeah.
common workflow language and so on. So I think that might be a possibility to see if we can collaborate with those rather than inventing the wheel or specific requirements. But nonetheless, I think that's a lot of overlap.
Yeah, how many people have used Galaxy before? I'm curious. Yeah, not many in our community.
Oh yeah.
Oh yeah.
But we use for programmer, we typically use Kepler. I mean, we use a lot of Kepler, but I mean, we're not necessarily married to anyone particular component. One question I did have a couple times near the end, you saying we were like, now is that like we is like the whole side we, or like we is who is we here?
So we got a lot of folks together involved in this to try to identify opportunities for MULSI to get involved in helping nucleate something. So the hope is that we find the right set of people who are interested in actually putting together a prototype. Aaron Vership, who just moved from Autodesk, was involved in this as well. Also, we need MULSI engineer time to help us cement this, but like I said, they're still looking for biomolecular people, so their bandwidth is kind of tapped out at the moment. So we're hoping that, or I'm hoping that in the next few months we can get the right people together and start to actually put together this prototype. But if anyone's interested, please let me know. We'd love to have you on board.
It seems like a lot of groups that have written like converter files to go from one format to another. They have their favorite flavor of that, and they have their favorite workflow they've already mapped out. If they can find if they can trace their way through this MULSI path, so it goes through one path, then that could be one piece that goes there, and then somebody else add-ons and have theirs go that way if they want to make an Amber file versus an Amber file or something. Because it is definitely a frustration for industry. Like we do want to try all these things and compare them, but we don't have an easy way of doing it. And I don't know how to, if I'm used to doing Amber a certain way and I don't know how to split the charge in the right way for GrowNext, it might affect something that I haven't really thought of and I notice it with me. So I'm at a loss immediately. So having experts to work it out in that level of detail, that would be awesome.
So we did have a session on interoperability, or a workshop on interoperability led by Teresa Windus at the Virginia Tech campus. Half of it was about quantum chemistry, and I think they're much more organized than we are right now. They actually had a separate meeting on a JSON format for interchangeability in quantum chemistry. There's a GitHub repo that MULSI is hosting, and you can actually participate in that discussion right now. I think progress along the molecular mechanics side of things to make, I mean, there's some great stuff from Michael Schertz, there's some great stuff from Jason Swales to interconvert some formats, but it's still, obviously a labor of love rather than a real software engineering effort at this point. So we're hoping that MULSI will take this up as well. There's some word that they are working on some universal parameterization database thing, but I'm not privy to what that is at the moment. But the hope is that we can actually, if enough of us say that this is really important to us, we need you to dedicate some time to it, and it will become a priority. It's their way of representing how you represent a molecular system that has parameters attached. But so I don't know. I wish I did. I'm sorry, they have it public now.
No, so they are working on that, at least according to the weekend I was at in January. They're working in that direction, but it's not public yet.
I see.
But if you follow them on GitHub, you'll see it when.
Okay, so it's Paul Sachs's project, though. Is that right?
Yeah.
Okay. Jeff had a comment.
Yeah, a lot of my 2 cents about that with sort of the file conversion problem with the loss of information when you're taking one file format into another. One thing that we noticed when we're sort of suggesting a way to put together workflows for Kelp is that preparation of biomolecular systems can be broken up into 2 stages. One stage being sort of like the addition of scientific information, so you start with an unrelated structure and you need to make some decisions about where they go. And that sort of information is going to be generic. Any document program will be able to use those positions to go on sort the documents just want them there. But then there's a second category of preparation that would fall into sort of the proprietary field. So things like converting to an NAE file and creating a grid that's specific for a document file. And when you think about modularizing a workflow, you want to put the generic steps up first so that the output from those generic steps can be taken and formatted in the correct way and information can be shaved off as necessary. But when adding information, that's where the step that should be containerized in one batch and the other.
I really like this. This is cool. How do you, but it seems to me the key is if you could get Schrödinger, OpenEye, Biovia, and CCG on board, right? That's the real key. So how do you do that?
Yeah, how do we do that, Greg?
So I've been working a lot with Orion, and it's been a real experience for me. I was an Amber guy for all these years, and I thought about MD in terms of carbon copy Fortran files. Then I started using OpenEye, and it was thinking about things in state files. Then, because of this whole workflow world, I've got to think about what's the common denominator. It kind of falls into the category of generic data that Jeff was talking about. My message is, for one thing, I think we need to change our heads about how we think about our science. What part is secure sense proprietary, or even if it's not proprietary in the company sense, but it's just your own bet, as like on John's slide there. And what is the primary language, the lingua franca, the information we need to hand around? So now I think about MD in terms of a Parnet object, because that's the most important interoperability we got. So now what we hand around between modules is a Parnet object. But I'm just saying that's about how to think about it. So my larger point is that as we think about workflows, we've got to think about it. I think this is my concrete contribution here, is putting the science into the module, and then having the module speak through some common language which still has to be worked out, perhaps with MALC, into a workflow language which has got to become more generic, because I know the Orion workflow language, and there's a Calc workflow language, and these have kind of bindings. These are common bindings which know how to work, passing on common bits of generic data. So what are those bindings? What is the generic data? In the generic data for a molecule, are B factors important? And I don't know if they're important enough, or they're proprietary, but they're only coming right now from the PDB files. So if you throw them away and you put them in generic data, they're gone. So figuring out that stuff is very important. And I think that's sort of the primary goal here. I'm sure you guys covered this, but I'm thinking that the bindings or the workflow language, otherwise we'll get the balkanization of the level of workflow language. That's my piece.
Jeff Skillman's here.
Ah, there. I didn't see you in the back. Just duck.
I mean, I think this is a really hard problem, right? I think that's the first thing to acknowledge. And that it's not just the transfer of data that's lost, the file formats themselves are lost. I think to be successful, you have to be able to handle data you don't understand. So you have to be able to handle an unknown blob and carry it forward as a tag and some piece of data that you can't parse. I think you have to handle cross-platform well. You have to handle NDMS transparently. You have to be really strongly versioned. And I think you guys have done a great job. It looks like pointing towards the macro molecules. It makes a lot of sense from your perspective. I think you have to sit down with people like Pat and say, how do you handle the small molecule data? Because if you don't do both those things, then you only serve half the community. And I think the way to get Schrödinger and CCG and OpenEye and Biovia on board is to talk to our customer. Because it's a no-brainer. If Pat's using it, we'll get it.
So, for a question, Pat, sorry.
Yeah, so to be very concrete, the thing Pat said about PDB foundation, you know, at least when I've done these things, there's no good format to pass around both the protein and the ligand. You have to end up using two different files. So one very small concrete case, could we just solve that problem? So we have one thing we can pass around, maybe an open binary or not that format, or some format that can contain both and retain the necessary information. You have a format that already works patterned, should we just run
I've always, this is one of the reasons that we did this with D3R, right? We split it out.
Yeah.
Because it was, I don't know a format.
Yeah, we have the same problem. It's like,
yeah.
If we want to put a protein in a mole tube, for a ligand, we have to have a mole tube. So,
Yeah.
Great. So, open it binary.
I mean, it's really hard for us to open that format without opening our entire code base. But we can talk about that as well as how do we open binary various pieces of it. I think we might all be better off looking at JSON, which we also support. But I think whether you're talking about OEP or JSON, it's important to realize those are text formats or binary formats, not file formats. You still have to worry about what's the shape of the data that you're sticking in there. Because otherwise you just get like another hacked format that you can put whatever tag you want, whatever data you want. It will like end up with a bin and zip problem, where everybody can read it, but nobody can read it the same.
So these kinds of persistent community-wide problems that are in want of a technical solution and some software scientist time and some commitment to support a tool that the entire community can use is the sort of thing we're hoping the MOLC can help with. So bringing this consensus to them is still going to be very useful, I think.
Yeah, is there any like also, what are there specific things that D3R can help to promote within this space, or ways that we can also incentivize, for example, people trying to put their vaccine programs anywhere in the area?
So can you put the workflow where you have the methods or by the way, in meta comment.
Oh,
we're talking about validated methods in D3R. The Luma thing basically somebody has it. There is no actual proof.
Of course.
It does anything.
Oh yeah, no.
It's supposed to do. It's great.
It got a bunch of scientists to talk to each other without serving the beer.
That's fine. So what I think is maybe the word of our question. So I love this idea. Needed and so I see the people in this room. People that are like to code, doing the envelopes, and that's great. And then people in this room, maybe a factor of 10 in the world over this, that now we can make the efforts on the blue thing, right? We can basically play with that thing and change parameters and change methods to see what the answers are. And now the more the users, which is everybody else except us, will take what we put up there and just use. And we end up with B3 everywhere. We end up with B3P everywhere. Why? Because everybody uses it. So if we put this out in tutorials and wherever, what we're going to find is the user base just using it blindly. And this is a big problem, right? Because we don't even know what we're doing.
So Jeff has the solution to that, right? If you have a leaderboard online with currently this is the best method, and we've validated it over new data coming in. There's a new competitor that emerges and takes over the top spot. I mean, we're not using AltaVista anymore, right? It was everywhere. We're using Google because it performs better, but now we'll have online data, and it could even be by target class. You could drill down and say, for this class of targets, this tool works much better. I think this will really enable a new kind of best practice.
So again, the software that you have to pay a lot of money for, that's a bad thing, but if you spend $5,000, maybe you convince somebody that you know what you're doing. Maybe not, right? If the software is totally free, you can go in a place and pick up Gandhi or the other version. Then you're going to do whatever the tutorial says. Yeah. And we get emails, you're in the mail list, I think, and we get emails like, you know, I got a sequence of 3,000 amino acids and something doesn't hold in the morning. What's wrong with that now? Because it's just a different story than lots of numbers. And
This is
and then we look like idiots because, you know, we lose face, so we gotta be careful.
This is a great question though. Like how do you somehow indicate that you're outside of the domain of applicability intended for a tool or that's validated for a tool, right? So in some programs have very locked down things where you can't use them in a way that's wrong. And it's really frustrating if you're trying to do science with it because you want to push those domains of applicability out to the edges, right? So I think that's a great problem that we can come together and solve too, because you could have like the child lock on so that you can't do that if you're just going to download it unless you show that you're an expert somehow. Go ahead, Jeff.
Yeah, and I think one thing that comes out of it is that, like Adrian said, you'll have to do some data set slicing at the end and figure out which method, or to see the results on problems sort of like yours. But also there are examples of this out in the world that work really well. And if you just open up a web browser and go to something like Cameo 3D, that is really brilliant. You go to that website and on the front page they have a scanner of the different servers that can try to do protein folding and how well they do. And there's a little bit of slicing you can even do there, like easy, medium, and hard, I think, based on templates and where you and so, of course, they could do more. There could be more slicing there, but just off of that, you see that some things are miles ahead, and that's really helpful. People are always going to be lazy because they stop using these.
I think Mike has that.
So my technical ignorance, but it seems like Singularity, it doesn't distribute the code, right? It distributes an executable.
Singularity Hub.
No, what I mean is if you transfer Singularity object, whatever, container to somebody that runs whatever they want, you let them do the run, but you haven't shared the code. Am I right?
So I'm not sure how secure the different options are. Like they're usually represented as file system layers that just layer onto something else. Usually in something like Docker, you can go into it, you can inspect whatever's in it. So in principle, you have access to the code. I'm not sure if Singularity provides an extra level of restrictive access where you can send data in and out, but not examine the internal components.
I guess I'm getting at is, my impression is you can distribute something that runs Singularity or Docker, but doesn't have the source code in it.
Oh, certainly, absolutely, yeah.
But I think we should really be thinking about source code as well, and how to. How not to just distribute something that you can run to reproduce my thing, and something that lets you figure out, well, I want to change something.
I'm a big fan of open source software. Like everything we do is open from the outset because I think that's the way we make progress is to learn exactly why something is failing, and you can do that more. But some of that's going to come from funding agencies or from journals to require that. In order to make progress and publish something, you actually have to be able to inspect what it is that was done. And reproducibility does require openness in that sense. So there's a good platform. I think Virginia Stoddard has a great article about the reproducible package for science, where it includes making the source code available under a license that actually people can do stuff with it, modify it, extend it, and making the data available by a Creative Commons license, something where people can actually reuse the data and change it in different ways, same with the documentation. So there is a well-developed concept of a reproducible scientific software product, and we just need to make the decision that we want to adopt it.
I was just going to say, okay, yes, just to round up my thought, I think what that says then is that Singularity and Docker in themselves don't fully solve the problem, they're a piece of the solution.
Oh yes, absolutely.
I'm just going to say, and then you'll want to think about how to have licenses that can transport wherever maybe you just want to run it a few times and it's like some per use basis or something like that. So you don't have to subscribe for an entire year or blah, blah, blah.
I think there's many models that could, you could license the software for use for like, my favorite is pay for IP, right? So you can always benchmark a piece of software on open public data sets if the results are open. But if you want to retain the IP of the molecules that you're evaluating with this, which is the really valuable thing, right? Then you'd have to pay for that usage. And that opens up a lot of academic research uses that are free. It opens up the ability to benchmark and actually see if it's going to work, but still the ability to, discover drugs, which is fantastic.
And as an intermediary, too, were you mentioning anyway? No, you're just. Also, as an intermediary, before you develop like a full-blown, automated workflow, which is a ton of work. What about sharing your notebooks as like an alternate, much easier solution?
I think it's a great way to interact with things. Like there's now Jupyter Lab, in fact, which allows you to have like entire environments that you share and do cool stuff within. Sharing like the suggestion of sharing a Jupyter notebook with all of the sample D3R data in it, which seems like a fantastic idea, because with a minimal installation environment that's just Conda or something like that, you can have all the data there, read it to pandas data frames, and then go through all of these standard analyses, and that would allow lots of eyeballs on the actual thing. But it's not a full solution, because sometimes like the tool requires a GPU, or it requires something else that has a really weird environment. Maybe it was written in Lisp or something like that, right? So Jupyter is getting closer towards being a reproducible research environment, or enabling that, but it's not a full solution. You probably need something in a container still.
I wonder, even actually, Pat, I'm thinking more about what you were saying this morning about the evaluations and assessment. If D3R should work on, we can look at Jupyter notebook flow for how, at least we can the first pass, what kind of assessments and evaluations we should be doing on different models.
That would be the integrity of the solution.
Yeah. It's nearly time for lunch, but we have like one more minute, and we haven't talked at all about if there's any additional feedback for Cal. And I know, Joaquin, did you have anything specific?
You had a slide, right?
Yeah.